Today we're going to look at fiber optic cable or fiber media. Essentially this is glass or plastic, very thin cable made of those substances that allows light to travel, and that light is used to carry the pulses that provide the data transfer. So let's go ahead and look at the desktop. Alright, so you'll notice the standards, the labeling is exactly the same as twisted pair media. Only difference is there's an F here instead of a T, and that designates that this is fiber. 100 base, 100 megabits, communication type is baseband, that's regular Wi-Fi. So 100 base FX, fiber segment providing 100 megabits of bandwidth. That would be very cheap fiber. I don't know why you would even want to use that. 100 base SX is fiber segment providing fast Ethernet over a short range, and that would also be 100 megabits. Once again, don't know why you'd use it. Gigabit for short range, that's what the SX stands for. And then LX is long range gigabit, 10 gig short range, 10 gig long range. Multiplexing is a consolidation of multiple digital signals into a single composite signal, so you're compositing multiple signals into one strand of fiber. Wavelength division multiplexing, basically you're using the wavelengths, so different colors of laser lights carrying multiple signals down one fiber strand. Unidirectional WDM is a wavelength division, multiplexing type where all active communication channels allow transmissions in one direction at a time. So it's like half duplex telecommunication. You can only either talk or you can listen, but you can't do both at the same time. Bidirectional, on the other hand, is basically allows you to talk and listen at the same time. So all active communication channels allow transmission in both directions at the same time. Coarse WDM is a WDM type with a total of 18 communication channels providing 10 gigabits of aggregate bandwidth. Dense is 192 channels, 19.2 trillion bits of aggregate bandwidth. Don't forget, you need to complete these sections here, participation and challenge activities. ANSI standard for fiber optic connector is ANSI TIA604. It's a series of fiber media standards specifying which fiber connector to use based on the type of fiber and the situation that you find yourself in. Angled physical contact, or APC fiber, is a connector type with 8-degree angled polished end and a green connector cover. So when you're looking at the different connectors, this particular type is color-coded green. Ultra physical contact, a slightly curved polished end and a blue connector color. So that's the difference. APC is green, UPC is blue. Return loss, the amount of loss caused by reflected light inside the fiber cable. You don't want the light bouncing inside the cable because if you do, you get attenuation. Insertion loss is the amount of optical power lost due to the fiber cable's length. It is possible to lose signal with extremely long runs, and so there are ways that you can counteract that, but for the most part you want to maintain the recommended cable length, and also if you need to you can use an amplifier. Straight tip or ST connector, it's a fiber connector using a twist on, twist off or bayonet connection method. Local connector is a small form factor fiber connector with a retaining tab. Subscriber connector is a square shaped fiber connector with a push on, pull off connection method. And mechanical transfer register jack, that is a small form factor fiber connector resembling an RJ45 with a tab locking connection method. It looks kind of like an RJ45, only it's bigger and a lot bulkier. These pictures will give you a general idea of what each one of those looks like, so make sure you go through the participation activity. Optical transceivers, device that converts electrical signal to light and vice versa. Small form factor pluggable transceiver is an optical transceiver up to a gigabase or gigabit Ethernet. Enhanced or E small form factor FP plus transceiver will handle up to 10 gigabit Ethernet deployments. Quad small form factor, you can carry 4 gigabits of aggregate bandwidth of 1 gigabit signals. And then enhanced quad basically allows you to carry 10 gigabits individual fibers for an aggregate bandwidth of 40 gigabits. Challenge activity, you need to be able to pick the correct media type for the situation, or which one matches up with each of these standards. And then once you've gotten that done, you can move on to the next section. Again, if you have any questions, let me know in the Canvas inbox or ask me in class. I'll do my best to answer. Have a good day.